and it just would not work. With a link, it would. I could either put a link or an image, but then I got a 404 not found on my image, which I just uploaded to my website, so there was an image there, but damn thing. So I'm just going to set up the text at the bottom of the screen for now, but I don't know if this is going to be live or not, but yeah, I'm just pulling my hair out about this because I mean, yeah, I don't like fighting about with software these days. I mean, I'm getting too old for all this bloody updates and all this badly thought out software. I mean, I think it was Bill Gates or someone. I hate Bill Gates. Well, I can't stand the guy. I think he said, he made a comment recently, apparently saying that the public don't deserve to have decent software, something like that. Anyway, something along those lines, or or the public can't afford really good quality software, something like that. But basically implying that we get a lot of crap and junk, which is what we do get anyway. Which is why everything is breaking and going wrong and everything else. Anyway, so I was coming live because I was trying to test this out. There was something I was going to talk about now, and I can't remember what it was. Because of all this upheaval with the application and the phone getting too hot and everything driving me up the wall, I can't think straight. You know, it gets you to the point where you can't think straight anymore. And I suppose that's the objective, is to confuse everybody and drive everybody to a point of desperation where we feel completely helpless. And that's what they want. They want us all feeling completely helpless and lost and disassociated with the reality of what we're trying to sort out and everything else. And that's when they disempower us, you see, keeping us in the dark about what we're really doing and everything else. I'm waffling again. So yeah, what was it I was gonna say? Something important. There was something important. Flipping heck, I can't think now what it was. Well, yeah. So for about 30-40 minutes I've been fighting with this flipping phone, trying to get this blurb at the bottom of the screen, whatever, and then every time I make the screen bigger, the text disappears and you can't see it anymore because it's on top. The screen's on top of the text instead of the text being on top of the screen. And there's no option in here to make it. It doesn't say send to back or bring to front or anything like that, which is what it should do if it was in English. You've got all these fancy numbers and characters and all these weird stuff that nobody can understand, which is completely useless. So you spend ages trying to figure it out, and then there's more chance that you break it by twiddling with digits and numbers and changing values and things like that. It's all designed for blooming rocket scientists. It's not designed for the ordinary guy in the street. Somebody that doesn't know software very well. I know batch files a little bit, but that's about it. But when it comes to the software side of it, they blind you with science so that you completely get lost, right? Absolutely, totally lost because of all these flipping XYZ symbols and everything else, and the values that you put in, like 2 or 1, and you think, what the hell's all this lot? So anyway, basically, yeah, I think I was something else I was going to talk about anyway, which is not the important thing, but the generator part of this. Let me just get this capacitor off here a minute. That one off there a minute. Right, the capacitor part of this, as in the inductance part of it, when I actually lift off the top section, right, which is the top actuator coils, we decouple the actuators, and when I do that, actually the power input drops down to virtually naught. Now, what I've been thinking about, I'll just stick that there a minute. It's pretty heavy as this, you know. So what I'm thinking is that the way I did my previous, just get this off of here if I can a minute. Though it's all still connected up. Actually, it'd be easier if I just do the other one. I'm going to wiggle it out. So my core materials that I actually put in there, which are the welding rods, they're actually copper coated. If you look, they've actually got copper coating on the because they're welding rods. So what I'm thinking is it's because of the copper coating that it's actually causing my impedance to go high, and it's basically causing a short circuit. And the reason why, when I put a load on the output coils, it's almost like the short circuit's been removed. It's because of the copper, the actual direction of copper that's in the core material that's in there is effectively reducing the impedance and the inductance in such a way that we get a high input current, but that input current just disappears when I put a load on the output, which is the opposite of conventional transformers. Now, I've got this new core material coming, so I'm expecting that when this new core material comes, I'm mainly going to be concerned because when I take this thing off, these actuator parts, take them off, the current load disappears to virtually nothing. I don't believe there's anything wrong with these sections. These sections work very well in resonance and everything, but the main focus will be to make better secondary cores, which is what I'm planning on doing, because these copper coated steel rods are part of the problem. Oh, what's going on here? Oh, I'm pulling that wire a bit tight. So part of the problem is in, oh, this is heavy. You know, this is about a kilogram when I'm holding this thing here. This is about a kilogram. It's heavy. Right, so right, back on that. Right, so that's what I'm basically trying to explain about this thing. Yeah. Anyway, I'm happy with it. It's, oh god, the phone's getting hot again. Yeah. Anyway, so I thought I'd do a little update on this. But there was something else I wanted to talk about, and I just can't think what it was now. There was something else I wanted to. Would it been a weekend? Well, it looks like the package that's been sent to me is at the departure airport in America for one item that a friend's sending me, and that should be getting put on a plane out to come to my country and get delivered. Hopefully, I'll get it before Christmas, and it's nanocrystalline core material. That's going to be fun. And the other core material from China, which I ordered, which is soft ferrite or something, that could be middle of January before I see that. God knows when that's going to arrive. It's probably going to be later than the stuff. Oh yeah, something else I'll show you. When I better turn this thing back on again. Right, turn that on. Right. When the actual voltage that I'll just switch this on. Right. When the voltage that I'm sending my output from this device into is about 4 volts or less, I actually get an output, really decent output. I'm going to show you what that is actually while I'm here. I'm going to put the probes back on the digital meter because it's a lot easier to see it. Don't fall. I was just going to say don't fall over on me, and it did. Right, ooh. Right, this lead's a bit short. Right. Right, stand up. Meter, stand up. Right, I think I've got it. Okay, so right, I was gonna do some live streaming with this other camera, but I decided just to use my phone because I was messing about the other day with that thing. So on the digital meter, I'm going to switch this on for a minute and show you what happens. But the output current is pretty decent when we're actually charging into a virtually zero load. I'll put my meter on so you can see what voltage we're going to be going into. Let's turn it on. Let's look at the current. Right, we're 183 milliamps at the moment. That is going into a 5-volt load, which is not bad. My input current with that load is about 50 milliamps at about 35.5 volts. So it keeps on doing that decimal point thing with me, like 0.48, but it's actually, I set it to 35.5, which is what I set it to, but it keeps dropping down to 48. Anyway, we're at 50 to 60 milliamps with a high load. On the high side, and as you can see, look at that, we've got 180 milliamps. Near enough, but it's dropping obviously as the voltage starts to climb on the supercapacitors that we're putting the power into. The current will start to drop slightly, but that's better than it used to be. If you remember, we never had that. We used to get maybe 150 or something, but that's a big improvement. Yeah. On the low side at the moment is before it's been stepped up to the higher voltage is, let's see, 225. That's at 16 volts. Is that right? 16, 17. Yeah, 16 volts DC. So 16 volts, we're actually on the low side. Yeah. So anyway, we're doing actually a lot better than we were previously. So anyway, just wanted to show you that. So I'm making progress slowly. Anyway, I'm gonna go because until I get that other cord material, there's not much more I can do with this at the moment. I could wind more cords, but I'm running out of copper, to be honest with you. This heavy gauge stuff that's on here, on the secondaries, I would really like to wind some bigger secondaries on here as well, but I haven't got the money to buy the copper right now, so that's like £15 for 500 grams, half a kilo. Every time I want to buy copper to increase to bigger coils on it, the bigger wire, the thicker wire, you know, we're talking about the 18 SWG or the 20 SWG. No, it's actually 18, I think, or 22 SWG. 22, I think, is what's on here. 22 SWG. But every time you use that kind of copper, you go through it really quickly because it's thick wire and there's not as much on it, so you end up using a lot more of that than you would with the thin stuff, really. But the thin stuff tends to be on these on smaller coils, really, but these are pretty big coils. Yeah, anyway, I'm gonna go. I'm gonna hope that this is gonna work, this live stream. It's probably gone back to unlisted or something again, I don't know. Okay, see you later.